Okay, my third and final video on volume of revolution, but this time we're going to find a volume of revolution using a parametric definition of a curve. So again, like the previous two videos, I'm going to start with a general curve, looks something like that. I'm going to assume we're going to be rotating it around the x-axis, although it's around the y-axis, then just take all the x's and y's and swap them over. The problem with this curve is it's not y as a function of x, so we can't use the same theory as we did a couple of videos ago directly. However, we are given a definition as x is some function of t and y is some other function of t. Okay, so this is what we call a parametric definition, and that is studied in A-level mathematics. So we're going to go from x1 to x2, and this area here is what is going to be rotated around the x-axis, and we want to calculate what volume the shape has that's been rotated. So we call back a couple of videos. Volume of revolution around the x-axis is equal to pi times the integral between x1 and x2 of y squared with respect to x, which is true. However, we've got an issue because this is not a function of x. I mean, if you can make it a function of x, then great. You can, of course, plug that into this. But let's assume we can't. This currently is a function of t. In fact, it's g of t squared, because that's the definition of y. It's a function of our parameter. Now, you can't integrate a function of one variable with respect to a different variable. So we need to correct this. And the way we correct it is we need to somehow replace the dx with a dt. Obviously, can't do that directly. And you need to replace the limits. X limits don't work. You need to replace them with t limits. So how do we do that? Well, we've got pi times the integral of y squared. That's all fine. But instead of writing dx, I'm going to write dx by dt times dt. Now, I know dx by dt is not a fraction, but for A-level mathematics, and for most of further mathematics indeed, it behaves exactly like a fraction. So dt and dt, they will cancel, if you like, and we're left with dx, which is where we started. This is the process that's taught in A-level mathematics when you're asked to find the area under a parametrically defined curve. So why not do the same here in further mathematics? The other thing we need to do is we need to find the t limits, t1 and t2, and t1 is the t value at x1, and t2 is the t value at x2. Once we've made those changes, then we can use this formula of volume of revolution around the x-axis is equal to that thing instead. So it's very similar to your parametric definition for areas from A-level mathematics, but obviously we're finding volumes now instead. All right, so let's see this in action. I have one example. We have a curve C. It has parametric definition x equals 2t squared, y equals sine t. The region bounded by C and the x-axis is rotated 360 degrees about the x-axis. Find the exact volume of revolution that is formed. Okay, so the first thing to notice is there's no numbers on my diagram that I've been given. But I am told that it's the region bounded by the curve and the x-axis. So this whole region here, that is the region that is going to be rotated around the x-axis. So I need to find the t value of here, which must be the origin, or if it's not the origin, then we need to find out what that t value is when it hits the x-axis. And this one here. So we need the t value here, t2, and the t value here, t1. So how do we do that? Well, at both of those points, y is 0, because the region is bounded by the curve and the x-axis, which means the curve has to touch the x-axis at these 2 points, which means y is 0, because that is the equation of the x-axis. So if y is 0, that tells me that sine of t is 0, and that tells me that t is going to be some multiple of pi. 0, pi, 2 pi, we don't know exactly yet. We should also consider what happens here. When t is 0, x is 0, so that looks promising. When t is 0, when t is pi, x is 2 pi squared. And when t is 0, when t is 2 pi, x is 8 pi squared. So given that on the sketch, this is the first time that it touches the x-axis after it leaves what looks like the origin, then it would make sense that we're at this point, which means that t is pi. And we can further confirm that by considering what happens between t values of 0 and pi in the y direction. Between 0 and pi, y will be positive, because sine is positive between 0 and pi. If we look at our graph, we can see that all the way between there and there, y is positive. Okay, further corroborating that t is 0 is here, and t is pi is here. Okay, so that's our t values. And now we can plug what we need to into that formula, which I derived on the previous page. So the volume of revolution around the x-axis is going to equal pi times the integral between my t limits, 0 and pi, of y squared, so that's sine squared, times dx by dt, which is 40, dt. Okay. So that bit there is the y squared. That bit there is the dx by dt. Okay. Which means by extension, that whole bit there is dx, if you like. Not that we need that. This integral contains only t as a dummy variable. So we can now just crack on with regular A-level mathematics methods to solve this problem. Okay, so let's tackle this in a bit more detail. We've got, I'm going to write this as pi into 0 to pi of 2 times sine squared of t times 2t dt. And the reason for that is because whenever we want to integrate a trig function squared, we should be looking to use the double angle formulae for cos, and we know that 2 times sine squared of t is identical to 1 minus the cosine of 2t. Okay, that is, again, from A-level maths. So we're going to take that definition and plug it into there, and then we can expand the bracket, that times the 1 and that times the cos 2t. So that's going to equal pi times the integral from 0 to pi of 1 times 2t minus 2t cos 2t. dt. Okay, right, now we've got this situation, and you should recognise, again from A-level maths, that this is an integration by parts. So I'm going to set u to equal, because it's 2t. U to equal, let's go with t, which means u primed is 1 in this case. The prime is differential with respect to t. V primed, that's going to be the 2 cos 2t. And then the v is going to be sine of 2t. And I took the 2 here in with the v primed because that would cancel with the 2 inside when I integrated, and you can see that it's gone. If you didn't put it with it and you just left it out the front, it's not a problem. You just get a half kicking around, which you can deal with. You're further mathematicians, so we're all good. All right, so that's going to be pi times the integral between 0 and pi of 2t, I've not touched that, minus, oh no, sorry, I've integrated by parts. Let's just split these two up. So 2t dt. Right, let's leave that one alone. And then let's focus on this one. So then I've got minus pi times that, which is uv. So that's going to be t times sine 2t. And that's evaluated between 0 and pi. And then I've got subtract the integral, but I'm subtracting a negative, so plus the integral from 0 to pi of vu primed, which is sine 2t dt. Okay, almost there. Integrate 2t, that's t squared. That one's already been integrated, so I can put the minus t times sine 2t in this square bracket now. And now I can integrate the sine 2t here, which comes out as being minus a half cos 2t. And again, all of this is evaluated between 0 and pi. So all the integration is now done. Let's plug in the limits. I'm going to get pi into pi squared minus sine of 2 pi is 0. Cos of 2 pi is minus 1, so that's going to give me minus a half. Sorry, cos of 2 pi is positive 1, so it's going to give me minus a half. Plug in 0, so that's going to be minus 0. Plug in 0, that's going to give me plus 0. Plug in 0, that's going to give me minus positive half. And we can see that the negative and positive half cancel. So actually I'm just left with pi cubed. And that's the answer. If I took this volume here and I rotated it 360 degrees about the x-axis, then its volume would be pi cubed. Thank you very much for watching. If you have any questions, then please drop a comment.